In this video, we're going to see how we can perform static routing. Routing, simply put, is the process in which we set a path for a packet to travel from its source to its intended destination. For example, if we want to send a packet from a PC connected in the LAN environment that is connected to this router, and this router is acting as the default gateway, and we want to send a packet from this PC that is a LAN PC of location A to the PC that is connected to location C. And if you can see that these two links that are connecting these locations is a serial link. Whenever we use a serial link in packet tracer, we are simulating a WAN connection. That means that these locations are they might be on a different city, they might be different branches, they might be different countries. Okay, so this communication is happening in between these routers on WAN, or simply put, via internet. Okay, so if we want to send a packet from location A's LAN PC to location C's LAN PC, what happens is there are different routing mechanisms involved, okay, that route their packet from the LAN PCA to the LAN PCC. Okay, so in this video we're going to see how we can define those routes that let the packet generated by A to reach the destination at location C's LAN PC. Okay, so let's start the configuration. Before we do static routing, we are going to perform some basic configurations like the IP addresses and etc. Okay, so the first thing is we should get the links up and running. So let's perform that, and keep in mind that whenever we are simulating a a WAN network, that the serial cables have two sides. One is DTE and the second is DCE, as you can see listed here. The DCE side has an extra command clock rate applied on it. So when we are doing the configuration, we should keep in mind that we have to apply the clock rate command here. Okay, so the LAN A has been given IP 10.100. The LAN B PC that is connected to its LAN is 30.100, and the location C LAN PC has a 50.100 IP address. So now we're going to perform configurations on the router. Let's give a configuration terminal and then int fa00. So this is the interface that's connecting this LAN environment to the router. So let's give an IP address of, since it was 10.100, so it should be 10.1. As we have already mentioned that we give the gateways the .1 IP. Okay, it can be different, but it's kind of a convention to give .1. Okay, so the gateway is 10.1 and the subnet mask 255.255.255.0. Okay, so apply the no shutdown command and the link is up. Next we have to give IP address on the serial link here. Okay, so serial link IP address 192.168.20.1 and its subnet mask. Okay, and no shutdown. Now this link is not up, even the no shutdown command has been given. So what happens is whenever we are dealing with serial links, we have to up the links on both sides. On this side it's up, but on this side it's not up. So when both of the ends are up and working, this whole link will be up, otherwise it will be down. So The basic configs on lab A is done. Let's go to the location B and enable configure terminal interface 00, and let's give IP address. This has the 30 network ID, so 30.1.0, and no shutdown command. So the LAN network is up. Let's move towards the serial link. So IP address. Keep in mind that whenever we are dealing with routers, every interface needs to have a different network ID, otherwise it won't work. In a LAN environment, we can have the same network ID or different network IDs, but on a router, we need to have a different network ID on each interface, otherwise it won't work. Okay, so this one is 20.1. Since this is connecting to that, so these WAN links or these serial links can have the same network ID because this is a direct connection. So between a direct connection, it's connecting the same interface. So 20.1 is not used here. So these WAN links can have and should have the same network ID, but on the other interface, for example, this is one interface, this is one interface, and this is another interface, this cannot be same. Okay, they cannot be same network IDs, otherwise it won't work. It will give you an error. Okay, so not 20.1, it's 20.2 because 20.1 was configured on this side. So let's give it 20.2, and this is the DCE side, so clock rate should be applied. For example, I'm going 64 kbs, and let's apply the no shutdown command, and just like that, since we didn't make any mistake, this link is also up. Okay, and one thing I didn't do was write the configuration, so I'm going to go back to location A also, and you can see the messages here also, the up message. So Control Z and apply the write command to save the configuration. So now I'm going to go, sorry, there was another interface, this one, we missed that. So configure terminal and in serial 0x1. Okay, and IP address is 192.168.20.1, sorry, 255.255.0, and it's also DCE, so apply the clock rate command and then no shutdown, and yes, now apply the write command. So let's go to location C. Okay, press no en configure terminal and go to FA00 IP address. This is using 50 network ID, so no shutdown. So the LAN link is up. Let's go towards the WAN link. So WAN link is on 000, and IP address is using 40.0 network ID, so 40.2 because one was already applied on the other end. So subnet mask, basic, and no shutdown. And since we didn't make any mistake, all the links are up and running. So let's save the configuration. So right now what we did is we have upped our links, and let's check some basic commands. For example, if we want to ping, for example, 192.168. This is 10.1. Okay, so it's working. Okay, so let's ping 20.1. It's not pinging. Let's see if it pings or not. Okay, it's not pinging. So let's try what was the original intent, that we have to ping 50.100. Okay, so let's see if it pings 50.100. Obviously it's not getting past here, so how can it go towards it? So now what we have to do is we have to create a path that will tell this ping packet how it can go from here to here and here to here. So how routing works is, in computer networks, routing is the selection of the best path. Okay, so we have to define that best path statically. Statically means that we have to tell our packet that, for example, if it's intended towards this one, so how is it going to reach to the LAN PCC of location C? So how it works is that every router only knows the router that is connected directly to it. Okay, and the next hop address, whenever a packet travels from one router to another, it's called a hop. Okay, and it, for example, when the packet travels from here to here, it crosses one router, it's called a one hop. Okay, so whenever we are doing static routing, we have to provide the next hop address. Okay, and the next hop address is always of the router. For example, we are on location A and we want to give the next hop address, so it will be the interface, this one, that is connecting the location A to location B. Okay, so the next hop address is the IP address of the interface that is connecting the router on which we are performing the static routing to the next router. Okay, and the link should be a direct link. Okay, like this one. Okay, so for example, this is location A and we're performing a static routing. So this DCE link, the serial 00 links IP address. Okay, this will be the next hop address of all the static routes, because location A can only send traffic to the right side. Okay, B has two sides. B can send traffic towards A and towards C because it's in the middle. Okay, so it can also move towards left or towards right. C, same way, has only one direction because it can only move towards B, and it only knows the IP address or the next hop address of B, nothing else. It can only say that, for example, C has to send a packet to A, so C will send that packet to only to location B. It can only forward it to location B. So location B should have the information. Depending on that, it decides that whether it should be sent to A or it should be sent to B. We cannot provide directly the next hop address of A, okay? Because we don't do that. We only know what's only directly connected to us, okay? So let's start it. Hopefully you will get some clarity on that. So before moving onwards, let's see what happens if we give this 10.1. Let's rerun the 20 command. You see, now 20 is accessible because gateway is required for the communication, for the message to travel back. It can send the packet to 20.1, but it cannot travel back to the PCA. That was the problem that was being faced here. Okay, that's why the ping was not successful. So what happens is, this is the command show IP route that shows a routing table, and the routing table by default contains only the directly connected network IDs. Now you should be able to understand why we do not use the first IP of a network. Okay, that's the 0 IP because it's being used by the router's routing table to send traffic from the source to destination, and the directly connected are already in it. So let's perform some routing, and how it's done is we're going to go towards the IP configuration and then IP route. Now, which network ID's route we want to give. So what happens is, if we are working with routing, we ultimately want to go towards a fully converged network. A fully converged network means that we can ping each and every node of each and every network. Okay, so right now, if we uh, take an account of all the networks, this is 10.0 network, this is 20.0 network, this is 30.0 network, this is 40.0 network, and this is 50.0 network. So in this current situation, we have 5 networks in total: 10, 20, 30, 40, and 50. Okay, so 10 and 20 are directly connected here. So what are the missing ones? These are the 30.0. Okay, now next we are going to provide how many bits are being used for the network, as /24 or more than that or whatever. Okay, or less than that. So subnet mask, and now the next hop address. Okay, if you give this, then this is the next hop address, forwarding router's address. Okay, so what is the next address? This one, and that is 40.2. For example, 192.168. So no, sorry, 40.2, 20.2, 20.2. Okay, so that's an entry for 30.0. Now let's add the similarity, because it can only go in one direction. There won't be any change in the next hop address. It will remain 20.2. And then let's add the route for the last subnet, that is 50.0. Okay, so that's all. That's how you configure static routing. But if you apply the command show IP route again, okay, these are the routes that are present here. So let's try to ping again. For example, ping 50.100. So if, let's see if it's ping. No, it doesn't ping. Okay, let's see if it pings 30.100. It's not. Let's see. Yeah, it's not pinging. Okay, is there anything missing? Let's see. It doesn't have a default gateway. So let's see if it pings now. It's not pinging. Why? If you go here, it can ping. We have provided, no? We have provided, so 30.1 is pinging, and oh, sorry, let's ping 20.2. It's also pinging. Let's ping 20.1. It's also pinging. So it's also pinging this one. It's also pinging this one, but it's not pinging this one. Why? So let's see that. For example, open our route here and enable and show IP route. So as you can see, we're pinging a 10.100, and it only contains 20, 30, and 40. It doesn't contain 10 ID, and it doesn't contain the 50 ID. So that's why it's not pinging. So we have to first add the entries for that. So IP route 192.168.10.0. This is a network we want to provide route for, and its subnet mask. And now we have to see in which direction this 10 is. Okay, so 10 exists in on the left side, so the interface that is connected to the left side of location is the location A, and it's this one, and it has the IP 20.1. So this will be the next hop address for 10.0 network. So what happens for 50.0? So will it remain the same? Sorry, or not? It will change because now it has to go towards this one. So when it will forward traffic to this side, it has to provide the next hop address of this interface that is connected to location C, and that is 40.2. So it will become 40.2 and apply and show IP route. And as you can see, these are the two routes that are added, 10 and 50. So let's again, let's think from here, 30.1, 20.1, and let's ping, for example, 10.100. So as you can see, now we can go from 30 to here, or from 10.100 to 30.100. So now we can forward a packet from here to here, but not here. As you can see, if you ping 50.100, it's still not possible because can go towards here. It's also missing the default gateway, but still it won't ping. Why? Can someone differentiate in their mind what happened? So right now what happened is, this is the routing table for location A. It contains information for 10, 20, 30, 40, and 50, and it's sending towards B. In B, it contains 10, 20, 30, 40, and 50. But in C, so that's why we can communicate from A and B and from B to A. But if we, sorry, let's take some time and restart it. So if we're going to check, and I again did the same mistake, sorry about that. I was pressing the enter, and then for some reason I pressed that. Okay, so let's go to enable modes, and let's first apply show IP route. Okay, so if you can see, it only contains information for 40 and 50. So as we talked about, whenever we're going to make a routing decision, each router has to make the decision depending upon its routing table. So when the packet was sent from here to here, we sent it towards here. The packet arrived, but as you know, the echo reply has to send it back. But when the message was received here and compared with the routing table, it didn't contain any entries for the 10 network, so it didn't know where to send the packet, so it discarded it. So now we have to do routing here also for 10.0 network and provide the next hop address, and as you can see, it can only go towards B. Okay, so this would be 40.1 would be the next hop address. Okay, and it will remain the same for all the other routes. So 10, and let's set for 20, and then let's set for 30. Okay, you can just press the up arrow to repeat your previous commands and then edit it using right and left arrows. Okay, it will save you time. 30, and let's save the configurations and show IP route, and we have the 3 routes. So now if we do a ping from here, it should reach here. Okay, so now again, if we test from this side 50.100, it should get reply. So this is the process how we can do static routing. As I said, you can use a switch here and attach multiple PCs, making a full-blown LAN network. And but since we were focusing on the configurations performed on the router, I only used a single host as a LAN PC. Okay, but you can use multiple PCs. So this is how you can perform static routing. Hopefully, you will get a better understanding, and in our next video we will try to do some dynamic routing, in which we will be using some protocol to do all this process. Okay, so until next time, take care.